Welcome back to the Probabilistic Pod, the only show on the internet that's currently in a state of superposition. I'm simultaneously thrilled you're here and deeply concerned about your choice in hobbies. I'm your host, the one who spent 3 hours yesterday trying to explain to my cat why his bowl being half empty is actually a matter of observer perspective. He wasn't impressed. You probably won't be either.
If you're new here, we take topics that are way too smart for us and strip them down until they're just as confused as we are. If you're a returning listener, seriously, did you not learn your lesson the last time? Well, your commitment to existential dread is inspiring, so let's get into it. Today, we're opening a case file on the next big thing. And no, I don't mean another AI startup that just puts a hat on ChatGPT and calls it innovative. We're going deeper. We're talking about quantum computing.
To really understand this enigma, we first have to profile the main suspect in today's tech story. Because if artificial intelligence is the annoying younger sibling who won't stop bragging about how it can generate a picture of a steampunk capybara in 5 seconds,
then quantum computing is the mysterious cousin who lives in a basement cooled to negative 273 degrees Celsius and claims they can see into the fifth dimension. Look at the rap sheet. AI is the software rockstar of now, with a $1 trillion valuation built on code that sometimes, just makes things up. But quantum, that's all about the hardware. It's the future, valued in the billions, and its big problem isn't hallucinating, is that it's plagued by actual physical errors. It's just fragile. And this really gets to the heart of why it's such a mystery. There's this old saying that you can explain quantum accurately or you can explain it in a way people get, but you can't do both. It's built on these bizarre, counterintuitive rules that just don't make sense in our everyday world. So, to profile this subject properly, we have to go inside its lair. And trust me, the living conditions are particular. This isn't something you can just set up in your garage. The requirements are insane. We're talking extreme cold, just a fraction of a degree above absolute zero. The whole system is so incredibly fragile that a tiny bit of light or noise, even someone sneezing in the next room, can cause it to collapse. And there's no blueprint. They're all basically custom-built massive lab experiments.
And here it is, Exhibit A. I mean, look at that thing. People call them gold-plated refrigerators, but it really looks more like a steampunk chandelier made of copper and gold that has to be colder than intergalactic space just to function. It's a beautiful, sarcastic dance between this will change everything and we have no idea how to stop it from breaking. And here's a wild clue in our investigation. The core components, the things called qubits, can be made from synthetic diamonds. Yeah, diamonds. And it's not just to be flashy. These diamond qubits can actually work in warmer, and by warmer I mean still incredibly cold but less ridiculously so, temperatures. Okay, like any good investigation, we have to follow the money. Why are we throwing billions of dollars at these incredibly delicate gold-plated refrigerators? What's the motive here? Well, the motive is big money. While AI is already in the trillions, you can see here that the quantum market is projected to hit nearly $100 billion by 2035. That's a massive bet on a technology that is, right now, mostly famous for being really, really good at being wrong. Which brings us to the hype. As this quote suggests, we're in a peak hype cycle. And speaking of things that require your engagement to survive, before we dive into why entanglement is basically just telepathy for nerds, let's talk about you. Specifically, your lack of a 5-star review. Are you trapped in a state of uncertainty? Well, you can collapse that wave function right now. Smash that subscribe button. Leave a review. Don't be an abacus person. Join the hive mind.
All right, now that that's settled, let's get back to the case. What is this thing's MO? It's high maintenance and expensive, so what's the ultimate power play? What is it actually supposed to do?
In a word, speed. But not just, a little faster. As Professor Sir Peter Knight puts it, we're talking about solving problems that would take the best supercomputer we have today longer than the entire age of the universe, and doing it in seconds.
And that's not theoretical. Google has a chip that solved a problem in about 5 minutes. That same problem would take the world's fastest supercomputer 10 septillion years. That's a 1 with 25 zeros after it. This isn't an upgrade, it's a whole new reality of computation.
So what do you do with that kind of power? Well, one of the biggest goals is to completely change medicine. Imagine simulating new drugs at a molecular level, discovering life-saving cures in minutes instead of decades of trial and error. That's the promise.
And the toolkit is huge. People are already working on quantum compasses that work underground where GPS can't reach,
brain scanners that are safe enough for kids, systems to manage our power grids so we don't have blackouts, and ways to make shipping so efficient it saves massive amounts of fuel. It touches, well, everything.
But with that kind of power comes a dark side. And this leads us to the most dangerous file in this whole investigation, the heist. The single biggest threat this technology poses to our digital world.
The target of the heist is encryption. It's the lock on everything. Your bank account, your private messages, state secrets, it's all protected by mathematical problems that are currently too hard for normal computers to solve. But for a quantum computer, those unbreakable problems are trivial. The threat isn't just that they could break some encryption, they threaten to break it all.
And the heist has already started. Cybersecurity experts call it harvest now, decrypt later. What this means is that adversaries are stealing and stockpiling huge amounts of our encrypted data right now. They can't read it yet. They're just collecting it, warehousing it, and waiting. They're waiting for the day they get their hands on a powerful quantum computer that can act as a universal skeleton key to unlock every single one of our secrets.
All right, my brain is starting to undergo decoherence, which is my fancy way of saying I need a sandwich and a nap. We've reviewed the evidence, the incredible promise, and the terrifying threat. So it's time for a verdict.
And honestly, this quote from Brian Hopkins says it all. The potential is absolutely mind-blowing, but the practical reality of making these machines work reliably, the jury is definitely still out. Is it the future? Probably. Is it a giant money pit that physicists use to justify buying fancy liquid helium? Also probably.
But hey, that's the beauty of it. Until we reach the end of the road, it's both. So we're left with this question. Is this thing a revolutionary tool for humanity or the ultimate skeleton key for our digital lives? For now, the case remains open. A massive, non-probabilistic shout-out to our producer, FireflyHaku. Much like a subatomic particle, Haku exists in multiple places at once, usually editing out the parts where I start crying about calculus. Thanks for listening, you glorious nerds. Go forth, stay entangled, and remember, if you don't know where you're going, you're probably just moving too fast to measure your position. See you in the next reality.